Hello and welcome back to section 4, and this is a section about the rational roots theorem, okay? And what we want to do is use the rational roots theorem to determine the possible roots of a polynomial function. And we also want to determine the roots of and factor a polynomial function. So what I have is this. What I have when we're trying to identify roots graphically, now let's talk about what a root is, okay? A root is a solution to a polynomial, okay? And you're like, okay, well, what do you mean by a solution? Polynomial, okay? And that means that's where the graph crosses at the x-axis, okay? So if we look at this one right here, if we look at this, this graph here, what we notice is that we have 1, 2, 3, 4 roots. This has 4 roots, okay, or 4 solutions, okay? So that word is something that we need to understand and, you know, kind of go in between and understand what it means. So let's go ahead and talk about the rational roots theorem, okay? So it says the rational roots theorem states that if P over Q is a rational number in lowest terms and P over Q is a zero of the polynomial, then P is a factor of the constant term and Q is a factor of the leading coefficient. Yikes, okay? Now let's think about this. What is P and Q? Now the way I like to describe it is that if when you have a function, say f of x, okay, is equal to, and let's start off with, say, q x to the, you know, n power plus plus some number p. Okay, so q, and let's write this down, that q is the leading coefficient in a polynomial, leading coefficient, okay? And the p is the constant, okay? And the constant is the number not attached to a variable, not attached to a variable, okay? So if I were to look at, say, a function like this, you know, what I notice is that this is my q, 2 is my q, and -6 is my p, okay? And so what we would do is we want to determine all of the numbers p divided by q, okay, that would be, and those would be possible roots, okay, possible solutions to that polynomial. So what you would do is you would take all the factors of -6. So you would take, you know, plus or minus, you know, 1 times 6, 2 times 3. In any combination of positive and negative numbers in that would multiply to give me -6. Okay, same thing with 2, okay? I would take all of those values of, you know, positive and -2, all right? So then what we do is we take the factors, or list all the combinations of P and Q. Now that's kind of a daunting process. What I do, okay, and Edgenuity, we'll see what Edgenuity does. What I do is I make a list and I just say, okay, I'm going to do plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 6, and I'm going to divide that by plus or minus 1, comma, plus or minus 2, okay? And so this is kind of the shorthand way of doing it. This is the short way of doing it, just so we're not spending a lot of time coming up with a bunch of different various fractions. You know, I could come here and I could say, all right, well, if I take, if I have 1 over 1, okay, so 1 is a possible root, okay? Also, what if I had -1 over 1? That's also a possible root, okay? And then I have plus or minus 2, so I'm going to do this. I'm going to do 2 and -2, okay, would be a possible ratio, okay, plus or minus 3. So I'm going to do 3 and negative 3, and then the same thing with 6. I'm going to do 6 and negative 6, okay? So then the other thing that I would do is I would say, all right, well, what about doing 1 over 2, okay? So I would list out 1/2, but I would also need to list out negative 1/2. Okay, now the nice thing about this is that, if I did 2 over 2, that's going to simplify to 1, and I've already listed that number out, so we don't need to do that. Okay, but the other number that I need to do would be 3 over 2. All right, so I would do 3 over 2, and I would also need the negative 3 over 2. So all of these numbers are possible roots. Okay, they're possible roots, which means that there are possible solutions. Possible solutions. And remember what that means. If they're solutions, these are values for x where the graph crosses the x-axis. Okay. Now, it's kind of a daunting task to write these all out. So remember, I do the shorthand way. They might ask you, and it depends on the numbers. Sometimes the numbers lend themselves to, giving you a pretty decent list. Sometimes not, but sometimes you get like a list that's like completely ridiculous. Okay, let me finish this up. The graph crosses the x-axis. Okay. All right, so what I want to do now is take a look over here. And so, if I have this polynomial here, f of x is equal to 3x squared minus x minus 4, what we want to do is we want to test the potential root to see if it is a solution. Okay, and so what I would do is one method is to use substitution. All right, so we want to determine, okay, are these roots? Is this even happening? So what you'd want to do is just plug it in. So I'm going to do f of negative 2/3, and let's see if that gives us 0. And that's the question. Does this give us 0? Okay, so let's test that real quick. Let's do f of negative 2/3, and I'm going to plug that in for x. So I've got 3 times negative 2/3 quantity squared minus negative 2/3 and then minus 4. All right, so then I'm going to do this. I'm going to do 3 times, if I do negative 2 squared, that's going to give me positive 4. Okay, and then 3 squared is going to give me 9. So I've got 3 times 4/9. Okay, and then I've got plus a 2/3 and then minus a 4. Okay, and so let's continue to see if what we get here. All right, so that's going to give me 3 divided by 9 is 1/3. So really this is 4/3 plus 2/3 minus 4. Okay, and so 4/3 plus 2/3 is going to give me 6/3. All right, so you get 6/3 minus 4, and that's really just going to give me 2 minus 4, which gives me negative 2. Okay, so this doesn't give me 0. This is, not 0. So this, f of negative 2/3 does not equal 0. Therefore, negative 2/3 is not a root. Okay, and that's what we're just trying to figure out. All right. Now, the other thing we could do is we want to test the potential root of 1/3. Now, probably one of the easier ways of doing it, it depends on if you thought this was easier, if you thought this was hard. What I'd want to do, probably the method that I will use the most is using synthetic division. So I want to set that up. I want to set up that process here. I'm going to go 1/3, and then I want to divide it out from this polynomial. And so I'm going to list out my coefficients, which would be 3, negative 1, and negative 4. Okay. So what I'd want to do is, and the question is do I get a remainder of 0? Okay, same thing. And so, I'm going to drop down my 3. So I'm going to take 3, I'm going to multiply it by 1/3, okay, and that's going to give me a value of 1, okay. So if I put a value of 1 here, then I'm going to do 1/3 times, and now I need to do -1 plus 1, which gives me a value of 0, okay? And then what happens is I'm going to do 1/3 times 0, which is going to give me 0, and then I'm going to take -4 plus 0, which gives me -4. Okay, and this is my remainder. Okay, and so my remainder is not 0. Okay, is not 0. Therefore, 1/3 is not a root. Okay, it is not a solution. All right, and that's what we're doing. All right, let's take a look at something where we have non-rational roots. And so what I would do if I'm doing a non-rational root, these are roots that are irrational, okay? Where, if I had a function like this, looking to see where it crosses the x-axis, what I get here, let me just do this real quick. If I were to take this polynomial, x squared minus 2, and set it equal to 0, okay, what I would do is I would add 2 to both sides, and then I would get x squared is equal to 2. All right, I'd take the square root, and so I'd get that x is equal to plus or minus the square root of 2. Okay, the square root of 2 is an irrational number. Okay, and you can't get the square root of 2 from your possible rational roots test. Okay, and that's not going to appear. So, these are all, with the point of this listing this thing out is to say, okay, where are my possible roots? Okay, and that's the idea. And let's take a look at another solution set. Okay, if I were to take, this graph here and say, all right, let me set this one equal to 0, x squared plus 1 equals 0, and I subtract 1 from both sides, then I get that x squared is equal to -1. Okay, which kind of gives us a little bit of a problem here. What I would then do is take the square root of both sides, and you get that x is equal to plus or minus the square root of -1. Well, I can't evaluate the square root of -1. That's not even going to give me a real number. Okay, and so you get x is equal to plus or minus I. Okay, so when you're doing this, when we start to solve these polynomials, we're going to get these numbers in the end that might be either irrational or complex. This is a complex number. Okay, and so the rational roots test helps us start the process. Okay, having this list helps us start to find solutions. Okay, because we're not going to get complex roots and irrational roots until we get down to like an x squared factor, and we're factoring that, and we'll kind of go over that. All right, so what I want to do is talk about factoring a polynomial using synthetic division. Okay, so what I first want to do, let's go ahead and list off the possible roots. Let me double check the P over Q, and Q is first. All right, so here's Q, okay, and here's P. And so I would do, the list of possible roots would be, P over Q, all right, and that would give me, the factors of -2 are going to be plus or minus 1, and then plus or minus 2. The factors of Q, which is 4, is just going to be plus or minus 1, plus or minus 2, and then plus or minus 4, okay? Now, the reality is, this is kind of a pain, okay? I don't want to sit here and take all of these possible combinations of numbers and use synthetic division to see which one gives me a remainder of 0, okay? The first thing I want to do, okay, and this is the first step, okay, and I'm going to put this in big bold letters here. The first step for this is to graph it, is to graph the polynomial, and that polynomial, okay, to determine what, to get a starting point, okay, to get a starting point. Okay, and the reason behind that is because, I want to get a starting point because I don't want to sit here and waste my time trying all these different numbers, okay? And so what we figured out is that, all right, well, we kind of know already that one of my solutions is going to be -1, okay? And that's kind of the idea. All right, so what I want to do is let's just use synthetic division and try -1 as a root. All right, so what I'm going to do is I'm going to drop down my 4. Okay, we've taken all these numbers, we've put all the coefficients here. I'm going to drop down the 4, and then I'm going to take -1, multiply it by 4, and that's going to give me -4. Now, if I add those together, that's going to give me +12. I'm sorry, -12. Okay. Now, if I take -1 times -12, that's going to give me +12. All right. And then that's going to give me -3 plus 12 is going to give me +9. Okay. And then once I take -1 times -9, okay, that's going to give me -9. So if I take 7 plus -9, that's going to give me, what is that, -2? Okay, and then I'm going to take -1 times -2, which gives me a +2. And then when I add those together, I get 0. Okay, so what I've done, okay, is I've taken my polynomial, 4x to the 4th minus 8x cubed minus 3x squared plus 7x, and I have minus 2, and I've factored that. I factored out a root of -1. Now, when x equals -1, okay, as a factor, I add 1 to both sides. Okay, and that's going to give me x plus 1 is equal to 0. So I factored this out, and I've said, okay, this is x plus 1. Okay, now my remaining polynomial down here is 4x cubed minus 12x squared plus 9x minus 2. Okay, and that's what I'm looking for. Okay, I'm looking to factor this thing. Okay, now the next thing I'm going to do is look over here at my graph and be like, all right, well, now I know that 2 looks like it's also a solution, like it's also a root. Okay, so let's try that again. All right, I'm going to do synthetic division again. I'm going to let x equal 2 be my divisor. Okay, so here's 2. And then I'm going to write out my coefficients that I had from the next one, or from my quotient. And that's going to be 4, -12, 9, -2. Okay, and let's solve this. Okay, let's use synthetic division on this. Drop down your 4. Okay, I'm going to take 2 times 4. It's going to give me +8. All right, if I do -12 plus 8, that's going to give me -4. Okay, and then 2 times -4 is going to give me -8. All right, and so then I'm going to do 9 times 8, or 9 plus -8, sorry, which gives me 1. And then I'm going to do 2 times 1, which is going to give me 2 over here. So I've got -2 plus 2, which gives me 0. Okay, so this is a solution. Okay, and so, what then you could do is then say, all right, well, then if I continue to factor this down, that's really just going to give me x plus 1. All right, and when x is equal to 2, all right, I got to set that equal to 0, so I'm going to subtract 2 on both sides, so I get x minus 2 is equal to 0. So this factors to x plus 1 times x minus 2, and then we're left with our quotient down here. And I take my quotient, I'm going to write this as 4x squared minus 4x, and then plus 1. Okay? And so now, now what we're going to do is we need to kind of figure out, okay, well, what is this? How do I factor this? Okay, and it looks like we're going to get 1/2, but check this out. So I'm going to factor 4x squared minus 4x plus 1. I'm going to use the box method now. Okay, so now once you get down to a quadratic, okay, and that's why we spent so much time working on quadratics, is because now, once you get to this point, you have a whole toolbox full of methods to factor that, okay? So I'm going to put 4x squared here. Okay, I'm going to put a positive 1 here. All right, now what I'm going to do is I'm going to do realize that these have to, my middle terms have to, these two numbers here have to add to negative 4x. So I'm going to do this. I'm going to do 2x and 2x here. And then I'm going to do negative 1 here and negative 1 here. And if I take negative 1 times 2x, it's going to give me negative 2x. And then if I take negative 1 times 2x, I'm going to get negative 2x over here. Okay, now if I add those together, it's going to give me 4x. Okay, so this is factored completely. So now what I've got, my next one, I've got x plus 1, I've got x minus 2, I've got then 2x minus 1, and 2x minus 1. Okay, now I could even rewrite it like this. I could even say that I've got x plus 1 times x minus 2, and then I've got 2x minus 1, that factor, quantity squared. Okay, so this is factored completely. Okay, I have factored this completely. All right, and it's important that we do synthetic division because then, you know, that helps us factor. I mean, we could plug these values in and get, you know, plug it into the function and get a value of 0, but that's not going to help us factor anything. It's just going to tell us that it's a root. Okay, so that's the idea. Now the other thing we got to talk about is the multiplicity of a 0. Okay, and the multiplicity of a 0. And a 0, remember, this is a root. All right, this is a solution. Okay, this is where the graph crosses the x-axis. Okay, this is where the graph crosses the x-axis. Okay, it all means the same thing. Okay, so I need to, those are important words that we need to understand. Okay, so when we say multiplicity of 0, it is the number of times the related linear factor appears in the factor form of the polynomial. So when you see this, okay, and it all deals with your exponent, okay, because you have a value of 1 here, an exponent of 1, my multiplicity here is 1. My multiplicity here is 1. But because I have this value twice, my multiplicity is 2. Okay, and that's what that means. All right, so let's list out our zeros. Last thing I want to do is list the zeros. Okay, and that's this. I've got x equals negative 1. I've got x equals positive 2. Okay, and I've got x equals positive 1/2. Okay, however, we need to list out the multiplicity because my multiplicity here is 1. My multiplicity here is 1, but here my multiplicity is 2. Now, why am I doing this? Like, what's the point of this? All right, the point of this is that your multiplicity, if I add these numbers up, I get a 4 out of that. My degree is 4. Notice how the number of solutions that I get matches my degree. Okay, we're going to talk about that in the next section, okay, but that's the idea. All right, so, you know, it's really important that we're able to do this and understand how we get this. I hope this wasn't too terrible of a section, kind of a long set of notes, but I had fun, and I hope you had fun too. We'll see you later. Bye.